Hello everyone. Today we're going to be going over some non-calculator skills for this year. So a few things you need to know. Estimation. With regard to estimation, if you are asked to round something to the nearest like tenth or hundredth or thousandth, you should know what that means so you can round your answer appropriately. It is expected for you to do some algebra, including solving inequalities. You're expected to be able to estimate the values of square roots without using your calculator. So for example there, the square root of 82 is approximately equal to something. So for example, you know the square root of 81 is exactly 9, so therefore the square root of 82 is just a little bit above 9. So you might estimate 9.1 for example. Moving on, you are expected to add, subtract, multiply, and divide rational numbers. This includes fractions, decimals, and integers. You should be able to do all those things without a calculator. Next, you're required to apply the exponent laws. So example there. You should be able to do that again without a calculator. You will notice there is a little bit of order of operations required in that particular example. So you should be able to apply the order of operations without your calculator. So proceed through brackets, exponents, divisions, multiplications, additions, and subtractions. And last, you should be able to do any combination of the above. So if there is a question that involves both fractions and square roots, you should be able to roll with that and figure out what to do. Alright, so let's go through a few examples. First up, what is the value of 2 to the 3 times 2 to the 0? So what is the value? It's looking for like what's the answer. So for example, if you had your calculator on you and you typed 2 to the 3 times 2 to the 0, it would spit out a number, and that's what the value we're looking for here is. Now we can use this space to do our working out. 2 to the 3 is, just 2 to the 3. 2 to the 0 is 1. Anything to the 0 is 1. So we're just left with 2 to the 3. So that's 2 times 2 times 2. 2 times 2 is 4. And if I multiply that by 2, that's 8. So the answer here, the value, is 8. Next, simplify and then evaluate this expression. So evaluate is another word that you need to look out for. That means what is the value, right? So what would your calculator spit out? We're looking for a particular number. I'm not looking for a simplified expression. We're looking for the number that this gives you. So let's break it down. If I just focus on the numerator, 3 squared to the 4th power, I need to, when we're raising a power to a power, we need to multiply the exponents. So that would be 3 to the 2 times 4, which is 8. In the bottom, this would be equivalent to 3 to the 1, 3 to the 1, times 3 to the 4, right? 3 to the 1, 3 to the 1. So it's implied that there's exponents of 1 there. And if you are multiplying things with the same base, you add the exponents. So 1 plus 1 plus 4 is 6, so we have 3 to the 6. So if you wanted to write this out fully, we would have 8 3's up top. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. And then we have 6 3's on bottom. So we can sort of divide these out one at a time, like pair them off. 3 divided by 3 is 1. That's also 1. That's 1. That's 1. That's 1. That's 1. So we're left with just 3 by 3. So 3 by 3 is 3 squared. Now that's simplified, but we also, so simplified, done, right? And we also need to evaluate. So 3 squared is the same as 3 times 3. 3 times 3 is 9. So that's the answer for that one. Okay, moving on to the next one. Solve for x in the following equation. So we want to get x on its own. So in order for me to do that, I'm going to bring all the x's to one side. So I'm going to go ahead and subtract x from both sides. So x minus itself on the left is just 0, so 1 remains. And 2x minus x on the right is just a single x, and we still have this 2. Okay, and so I got to get rid of the 2 in order to get x on its own on the right. So do the opposite. I guess I'll do that in a different color. So do the opposite of adding 2 to both sides, which is subtracting 2. And then that gives us x is negative 1. So x is negative 1. Good. Moving on to the next page. In simplest form, what's the value of this fraction? Okay, so 1/6, 1/3, and 2.5. So it would be, remember with fractions, if you're going to be adding fractions, you need the denominators to be the same before you can go any further. Okay, so the lowest common multiple of 6, 3, and 2 is 6. So 1/6 I can just leave as is. 1/3, if I multiply the top and the bottom of 1/3 by 2, 1 by 2 is 2, and 3 by 2 is 6. So equivalent to 1/3 is 2/6. And okay, so 2.5, so I can maybe just, so it's 2 plus 1/2, and 1/2, if I multiply top and bottom by 3, that gives me a denominator of 6, so that would be 3/6. So 3/6 is equivalent to 1/2. So there we go, 3/6. Okay, so next I need to add all the fractions with the same denominator, and I'll just treat this whole number separately. So I'll bring that to the front, 2 plus, okay, so then the rest of it, I just add across the top. 1 plus 2 plus 3, so 1 plus 2 is 3, plus another 3 is 6. So 2 and 6 over 6. 6 over 6 reduces to 1, so it's just 2 plus 1. So final answer is just 3. Alright, moving on, so we got some multiplication of fractions here. Multiplication of fractions, super simple. You just multiply straight across the top and straight across the bottom. Common question I get often is like, with this negative sign, is that attached to the 1 or the 2, or is it out front? Well, however you like to treat it. If you prefer, if it makes it simpler for you, you can attach it to the numerator if you like. You could even attach it like it's a negative 1/2. So you could have it as a negative 1 over 2. You could have a 1 over negative 2. It's basically, it's just like it's a negative, however you treat it. It wouldn't be a negative 1 over negative 2 because that would make it a positive. Okay, and then 12 over 1. Right, you can always write something over 1. So going across the top, negative 1 times negative 1 times 12 is just 12, right? Because negative times negative is positive. And then on the bottom, 2 by 3 by 1, 2 times 3 is 6, times 1 is still 6. 12 divided by 6 is 2. So the answer there is 2. Okay, solve for x in this equation. Express your answer to the nearest tenth. So that's what I was mentioning earlier. Tenth is 1 decimal place. So you're not going to be asked to define what a tenth is, but you're going to be expected to know what that means, right? If you ask whoever's invigilating the exam, whoever's supervising, what does a tenth mean? They're going to say, sorry, I can't help you. That should be something you should know. So let's solve this. 2 times x and 2 times negative 2. So I distribute this 2 on the left side. So we get 2x minus 4, because 2 times negative 2 is negative 4, equals 4x minus 13. Now we bring all the x's to one side and all the numbers to the other. I'm going to go ahead and bring all the x's to the right side of this equation so that I have a positive x coefficient. 2x minus itself on the left is 0, so I'm left with a negative 4. And 4x minus 2x is 2x. and then subtract 13. Okay, let's get rid of the 13, or the negative 13 on the right side. So the opposite of subtracting 13 is add 13. I do that to both sides. So negative 4 plus 13 is 9, and then that's 2x. Okay, and then last I need to get rid of this 2, so divide both sides by 2. So x is going to be 9 over 2. Now, that is a fraction. That's not what we're looking for, though. We're looking for something to the nearest tenth. So I need to divide 2 into 9. So long division. 2 fits into 9 how many times? 4 times, right? And then 4 by 2 is 8. So I subtract 8 from 9. That's 1. Tack a 0 there. How many times does 2 fit into 10? Well, 5 times. So that is in line, right, with the decimal underneath. 5 times. 5 by 2 is 10. 10 minus 10, 0. So the final answer to the nearest tenth, so 1 decimal place, is 4.5. Now, if it was looking for the nearest hundredth, for example, you would record 4.50. Moving on. Number 7, solve for x in the following equation. So kind of similar to the one we just saw. What we need to do is distribute this negative 4 into each thing here. If you like, if it makes it simpler for you, you can write that over 1. So next step we would have 2x equals, okay, so negative 4 over 1 times 1 over 4. So negative 4 times positive 1 is negative 4, and 1 times 4 on the bottom is 4. Negative 4 divided by 4 is negative 1. So I have negative 1 there. Next, I've got negative 4 times negative 3 over 4, or if you like, negative 4 over 1 times negative 3 over 4. Negative 4 times negative 3 is positive 12 divided by 4, right, because 1 times 4 on the bottom. 12 divided by 4 is 3. So we have plus 3x. Keep in mind that is a plus because we are doing negative by a negative, which makes it positive. Okay, and then we still have plus 4. So from there we can simplify the right side of this equation. We've got 2 integers there. So we got 2x equals 3x, right, because that. And then 4 minus 1 is just positive 3. So we have 2x equals 3x plus 3. I'm going to go ahead and get rid of that. So I'll bring all the x's to the right side. 3x minus 2x is just x, and then we still have plus 3. And then on the left, 2x minus itself is 0. And last, I just need to get rid of this 3. Do the opposite of adding 3. So subtract 3 both sides. 3 minus itself on the right is 0. So I have x equals minus 3. So x equals minus 3. All right, moving on. What's the value of 13.2 plus 0.05 minus 5.45? So this one was fairly well done. I think you guys have a pretty good grasp on this, but I'll go through it anyways. 13.2. So the trick here with adding, subtracting decimal numbers, you want to line up the decimals. So 0.05. You don't want to, in general, like sort of right or left justify this. So this sort of procedure would lead you to the wrong answer. So that would give you like presumably 7, and then where does the decimal place go? Do you put it here or there? And then there's a 3 and a 1. It's a bit confusing there. So what we need to do is just line up all the decimals. So we line up the decimals vertically, and then we don't have to sort of worry about where the decimal should go because we're doing it properly. Okay, if you like, you can add a 0 at the end there. just to sort of make sure that you don't add the 2 and the 5 by mistake. 5 plus 0 is 5, 2 plus 0, 2, 3 plus 0, 3, and 1 plus, I guess, 0 is 1. So we got 13.25. And then we need to, from that, subtract 5.45. Again, we need to line up the decimal places. So first off, 5 minus 5 on the right there is 0. That's fine. Moving on though, 4 subtract from 2, we can't do that, right? So we need to borrow from the 3, so that becomes a 2, and this becomes a 12. 12 minus 4, obviously if you want to do this your own way, up to you, but this is just kind of most efficient for me in terms of not using a calculator, so there you go. 12 minus 4, 8. Okay, and then moving on to this number, 2 minus 5 I can't do, so I can, like, if you like, you can think of it as like borrowing that, so that becomes a 12, right? And then 12 minus 5 is 7. So 7.80 is the final answer for that one. Okay, so some exponents, so a little bed mass. Make sure you do the brackets first, then the exponents, then the multiplications, the additions, and so on. So the stuff inside the brackets should be done first. So let's focus our attention on those things. So within the brackets in the numerator, 2 plus 2 times 5. So within this top set of brackets, I have an addition and a multiplication. According to bedmass, I should do the multiplication first and then the addition second. So I should go 2 plus and then 2 times 5 is 10. And then square it. And then in the denominator, 4 by 5 is 20. Okay, and then furthermore, the bracket in the numerator is 12 squared. And then in the denominator, I can do 2 by 20. So that'll be 40. Okay. So then I got 12 squared divided by 40. 12 squared is 144 over 40. Okay. If this is one of those things that's not on the tip of your tongue, you can obviously just multiply it sort of the long way. So 2 by 2, 4, 2 by 1, 2, add the 0, 1 by 2, right? So you do like 1 by 2, 2, and then 1 by 1, 1. So that's, when you add those, it's 144. Anyways, little refresh on how to multiply 2 by 2 digit numbers. Okay, so we have 144 divided by 40. It's looking for the answer as a decimal. So we need to sort of, for lack of a better word, divide. So long divide 144. So the trick here, this is like 40 decimal, and this is like 144 decimal. If you like, you can sort of move each of these so that it's an equivalent problem. So the equivalent problem there would be 4 into 14.4. So if you find that easier, you can do that. I think I will as well. So long as you are moving the decimal inside and outside the same number of times, that's all you got to do. And then it's an equivalent problem. So 4 fits into 1 0 times, 4 fits into 14 3 times with 2 remainder. So 3 by 4 is 12. 14 minus 12 is 2. Drop the 4 there. 3.6. 24 fits into, 4 fits into 24 6 times. 0 remainder. 3.6 is the final answer. Notice it doesn't say to the 10th or the 100th or the whatever. So 3.6 is a perfectly acceptable answer, I think. Okay, moving on. Order the rational numbers listed from smallest to greatest using the numbers 1, 2, 3, and 4. So it is important for you to read here. use the number 1 to represent the smallest value, and use the number 4 to represent the greatest value. So in these spaces, I should be recording a 1, 2, 3, or 4. I should not be recording what these equivalent decimal answers are. Okay, that is not what the question is asking you to do. So 9 over 25 rooted. So the root of 9 on the top is 3, and the root of 25 is 5. So as a decimal equivalent, I can do, so 5 needs to divide into 3. Okay, well 5 doesn't fit into 3, but 5 fits into 30 6 times. 5 by 6 is 30, so 0 remainder, so this is 0.6. So 0.6 equivalent, maybe I'll just tidy this up a bit. So this equivalent is 0.6. 3 divided by 4 equivalent is 0.75, and 0.7 squared. So let's maybe do that over here. 0.7 times 0.7. So the trick here, going back a few years, swoop those decimals until you have a whole number. So that's once, that's twice. So effectively you're just multiplying 7 by 7 now. So 7 by 7 is 49, and 49 decimal. So to sort of undo the swoops here that you made, you swooped it once, twice. So to get the final answer, you need to swoop it back to the left twice. So final answer there, 0.049. Sorry, 0.49, my mistake. And then here, 0.75 repeating, so that over bar just means it's 5, 5, 5, and so on, right? Okay, so the lowest here, what is the smallest value? Is the smallest 0.6? Is it 0.75, 0.49, or 0.7555, and so on? So the lowest is this. So the smallest is represented by 1, so I record a 1 there. The next one up is here, so I record a 2 there. And then between these two, it's pretty close, but I have an extra 0.00555555 with this number, so this one is very slightly larger than this one. So this is the largest, that's the second largest, so final answer there, 2314. Okay, next, what's the value of 100 over 25 rooted plus 36 over 9 rooted? We could write that like this, if you find it easier. Square root of 100 is 10, square root of 25 is 5, square root of 36 is 6, and the square root of 9 is 3. So moving on, the lowest common denominator of 5 and 3 is 15. So in order for me to turn these into equivalent fractions, I need to multiply top and bottom of this one by 3 and top and bottom of this one by 5. So the equivalent fractions then would be 30 over 15, and then this would be 30 over 15 as well. Interesting. So I guess, I mean, we could have recognized that this equivalent was 2 and this equivalent was 2 as well. So if I continue this, it's 60 over 15, and 15 fits into 60 4 times, or if you had recognized earlier that that was 2 and 2, you get 4. Excellent. Moving on. Solve the inequality here. Negative 3x plus 7 is greater than negative 17. So I seem to have seen a few answers that were just greater than negative 17, so it seemed to be just like sort of a partial transcription of what the question was asking. A few problems with this. It doesn't actually solve the inequality. It's just kind of like a partial sort of transcription of what the question is. Second of all, it's looking for the symbol number. Notice there are symbol numbers up here. There should be a single digit recorded in this space, not a symbol number, right? So it should be a 1 or a 2 or a 3 or a 4. That's what we're after. But so before we get to there, we actually need to solve this inequality. So it's basically like algebra, but we have an inequality symbol. So we need to get x on its own, right? So let's get x on its own. Let's remove the 7 from the left side. 7 minus 7 is 0. I'm left with negative 3x on the left. And negative 17 subtract 7 is negative 24. Okay, and now I need to get rid of this negative 3 on the left, so x is purely on its own. In order for me to get rid of that negative 3, I am choosing to divide both sides by negative 3. Now, if you're doing that with an algebraic equation, no problem. Nothing extra happens. But if you are dividing both sides of an equation, of an inequality by a negative number, the direction of that inequality flips. So negative 3 divided by itself on the left, so I'm just left with x, and then negative 24 divided by negative 3 on the right is 8, positive 8, right? Negative divided by a negative number is a positive. Now, what goes here? Should it still be that? Well, it should be this, because the direction changes. Notice the sort of alligator mouth is now eating toward the right rather than what it was originally, which was to the left. So the direction changes when you divide by a negative number with an inequality. Okay, so notice this is matching up with symbol 3. So I should put a 3 there, and the value is 8, so 8. So 3, 8 is the answer for that one. Okay, moving on. If x is negative 3, evaluate this expression to the nearest tenth. That means 1 decimal place. So everywhere I see an x in this expression, I'm going to put a negative 3 in its place. So negative 3 plus 8 divided by 10 plus negative 3. So let's evaluate. Negative 3 plus 8 in that numerator is 5. 5 over 10 plus negative 3. 5 over 10 is the same as 0.5 plus negative 3. So if you're thinking about a number line, 1, 2, 3, we're at negative 3. And if we add 0.5 to that, we get here. So we're at negative 2.5. So that's the answer for number 13. How many whole numbers between 39 and 160 are perfect squares? So that's, I think that was pretty well done. So 39 and 160. The next perfect square after 39, so 36 is a perfect square. That's not above 39. The next perfect square up is 49. That's 7 squared. And then 8 squared, 64. Then 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared, 144. That's one we looked at a little bit earlier. And 13 squared is 169. Notice 169 is above that. So between 39 and 160, which maybe like around there, there are 1, 2, 3, 4, 5, 6 perfect squares between 39 and 160. All right, moving on. So we've got some integer operations here. Negative 13 plus 7, subtract negative 2 plus negative 6. So we need to figure out what needs to go in that square. We can clean these up a little bit. So you can maybe use integer tiles if you want, whatever you like. So I can maybe just work my way left to right here. Negative 13 plus 7. So if you like, you can do 13 subtract 7, and then just keep the sign of the original numbers in the back of your mind. So subtract the smaller from the larger and keep the sign of the larger. So that'll be 6, but the sign of the larger is negative, so negative 6. Subtracting negative 2 is the same as adding 2. And then adding negative 6 is the same as subtracting 6. And then we're plussing something to make 0. Okay, negative 6 plus negative 6 is negative 12. Plus 2 plus something equals 0. So this 2 still just carried forward. Negative 12 plus 2. So if you think about like a number line, right, negative 12 is here. If we're adding 2, we're going 2 to the right. So that's negative 11, negative 10. So negative 10 plus something equals 0. What's that something got to be? Positive 10. Next question. Which point on the number line best represents the approximate value of square root of 90? Now, okay, so we need to approximate a square root. I know that the square root of 81 is 9 exactly, and I know that the square root of 100 is 10. So 90 is about midway between 81 and 100. So given that I know that the square root of 81 is 9 and the square root of 100 is 10, the midpoint, probably going to be about 9.5. So the point on this number line above that best approximates 9.5 is 0.5. So the answer for me is 5. Okay, moving on, a little bed mass. So make sure you do the brackets first, then the exponent. So 6 divided by, 2 subtract 3 is negative 1. And then we cube that. So negative 1 cubed, right? Negative 1 times negative 1 times negative 1, right? Not negative 1 times 3. Negative 1 times itself 3 times. Negative 1 times itself is positive 1. And if I multiply positive 1 by negative 1, that's negative 1. So 6 divided by negative 1. 6 divided by negative 1 is negative 6. Moving on. P and Q represent the two whole numbers closest to square root of 121 divided by 9. Alright, I can rewrite this as 121 over root 9. The square root of 121 is 11, and the square root of 9 is 3. Okay, so these are whole numbers here. Whole numbers meaning like 1, 2, 3, 4, 5, and so on. 11 over 3 is a fraction. What would that be as a decimal? So for me to figure that out, I need to divide 3 into 11. So 3 fits into 1 0 times. 3 fits into 11 3 times. So 3 by 3 is 9. 11 subtract 9 is 2. Okay, and then 3 doesn't fit into 2, but drop to 0. 3 fits into 26 times. Right, 3 by 6 is 18. 20 minus 18 is 2. And then, drop this again. So 3 into 20, 6, 18. So it looks like it's going to be 3.6 repeating, etc. So if this is equal to 3.6 repeating, that means this has got to be 3, and that's got to be 4. So P is 3, and Q is 4. Nearly done. Solve for x in this equation. X over 3 plus 7 equals minus 2. So one thing you can do, if you like, you can start by multiplying everything by 3. That gets rid of the fraction immediately. Alternatively, you can subtract 7 from both sides. 7 minus itself is 0, so I have x over 3. 7 minus itself is 0, and then negative 2 subtract 7 is negative 9 over 1, if you like. To get rid of the 3 on the left side, we need to multiply both sides of this equation by 1. 3 divided by 3 on the left is just 1, so we're left with x, and negative 9 times 3 is negative 27. So x is negative 27. last question, simplify and then evaluate. 3 to the 4th times 3 cubed. So if I'm multiplying two things with the same base, I can add the exponents. So that would be 3 to the 7. And then this one, 3 to the 7 times 3 to the 0. 3 to the 0 is just 1, so it's 3 to the 7 times 1, which is just 3 to the 7. So 3 to the 7 minus itself is 0. 0. Alright, so that's it for that. Happy studying. See you later.